In this stage, we're going to practice writing conditional statements and continue learning about test-driven development. Just as a refresher, the TDD process leads us through 3 steps for each piece of code we write.
Red.
Write a test and watch it fail.
Green.
Write the simplest code that we can write to make the test pass.
Refactor.
Clean up our comments, variable names, and any duplication in our code. We saw the simplest kind of conditional in stage 1. We use this kind of conditional when we are choosing to make something happen only in certain situations. After the keyword if, the parentheses contain an expression that evaluates to either true or false. If the condition is true, then the code in the then block is executed. If the condition is false, the code in the then block is skipped. So, an if statement is choosing whether we should execute the code in the then block, and that choice is decided by whether the expression in the condition evaluates to true or false. The second kind of condition is called an if-then-else statement, and we use it when we are choosing between 2 behaviors. We saw one of these in stage 5. In these, the then block is followed by the keyword else, and then another block of code. When these statements execute, the machine evaluates the condition. If that condition is true, the code in the then block is executed, and the code in the else block is skipped. If the condition is false, the code in the then block is skipped, and the code in the else block is executed. So, an if-then-else statement is choosing between 2 behaviors, the code in the then block and the code in the else block. The choice is controlled by the condition. If it is true, only the then block executes. If the condition is false, only the else block executes. We've been showing every conditional with curly brackets around the then and else blocks. Technically, you don't have to have those. The rule is that exactly one statement can go in each of those places. So if there's only one statement, like in this example, you don't have to have the curly brackets. When we want to put multiple statements inside the conditional, we're using the brackets to make one big statement out of a set of statements. As a general rule, it's considered good form to always include the curly brackets. This makes the code more readable, and it's easier to add more code within the conditional if the curly brackets are still there. If they aren't there, sometimes people will add another statement indented in that area and think that it's inside the condition when it really isn't. That one statement rule can cause some subtle troubles. Look at this code. Notice that semicolon after the condition in the if statement. The compiler will see that semicolon as the one statement that is inside that conditional. That means that the system.out.println line will always be executed. It isn't inside the if statement.
It's pretty easy to make this kind of mistake because our fingers get used to putting semicolons at the end of the lines. So, when you see code that you think is in an if statement, but it seems to be executing when it shouldn't be, look for that extra semicolon.
It seems pretty stupid that the compiler wouldn't warn you about that.
Good catch, Jejun. The more you learn about Eclipse, the more it can help you. You can have the compiler give you a warning there. Watch this. So here's our code from stage 1, and you can see if I run it, I get the output that we were supposed to get in stage 1. But if I had accidentally put a semicolon right there, and I run it, that print line, now that print statement happens all the time. So after the 4, we still see potato, even though it looks like it's inside this if. And that's because the semicolon is the one statement that the if is choosing whether or not it should execute. Now, Jejun's right. The compiler ought to be able to tell us about this, and in fact, it can. If I right-click and go to the properties of my project, and I go under Java Compiler to Errors and Warnings, I can say Configure Workspace Settings, and under Potential Programming Problems, one of the things is an empty statement, and I can change that from Ignore to Warning. If I just want a yellow squiggle, I can turn it to Error if I want the compile to fail under that circumstance. But if I say Warning now, it'll recompile everything. And now if you look, there is a yellow here, and it's saying there's an empty control flow statement. And there's a little yellow squiggle right underneath there as well with the same error. So when you know how to use the tools can help you catch mistakes like this. We can put any code inside of a conditional, including another conditional. This is called nesting conditionals. When you see code like this and you want to understand what it does, what should you do, Zumi?
Be the machine.
Right. So pause the video for a minute and see if you can figure out what the output is for each of these values of grade. What you should have seen is that when grade is bigger than 90, it outputs excellent and skips the rest because all of the rest of the code is inside the first else block. When grade is less than or equal to 90, the first then block is skipped and we go into the else block. In there, we compare grade to 80 and that chooses whether we output average or poor. The expression in the condition of an if statement can get pretty complicated. In addition to making comparisons, we can combine Boolean expressions using the operators ampersand ampersand for and, meaning both of the operands have to be true for the expression to be true, and vertical bar for or, meaning the expression is true if either of the operands is true. So, in this example, the condition will be true if age is less than 10 and height is greater than 60. So basically, if you're a child and you're more than 5 feet tall, you're tall. Both comparisons have to be true for the and to evaluate to true. Notice what happens if you aren't a child. If your age is more than 10, age is less than 10 will be false. So the and will be false, and we will execute the else block. So everyone who is 15 is short, even Michael Jordan.
We can do better than that.
Yes, we can. Essentially, we need to have a different cutoff for tall for people who are full grown. This condition captures that idea pretty roughly. It says if you're young and more than 5 feet tall, or if you're grown and more than 6 feet tall, then you're tall. Otherwise, you're short. Play with a few values to see how this works. You should be able to verify the results in the table. In the lab this week, you're going to be building a tax calculator. The lab will give you the tests, and the goal is for you to practice writing code that contains conditionals.